Theoretical recap. The hosts file is one of the oldest name resolution mechanisms in computing, predating DNS entirely. Located at /etc/hosts on Linux /macOS and c://system32/etc/hosts on Windows, it acts as a local static lookup table that maps hostnames to IP addresses. When your system resolves a domain name, the OS typically checks the host file before querying any DNS server. This priority order is defined in /etc/nswitch.conference on Linux. Look for the hosts line, usually reading files DNS. This means that any entry in your host file will override whatever DNS would have returned, silently and completely. A common mental model. Think of the hosts file as a local DNS shortcut that always wins. If you add 127.0.0.1 google.com to your host file, your browser will connect to your own machine when you visit google.com, regardless of what the real DNS says. Common mistakes include forgetting to flush the DNS cache after editing the file. On Linux, sudo systemd resolve flush caches, editing the file without root privileges, the changes simply won't save, or expecting the override to affect other machines on the network. It is strictly local. The hosts file is also a classic attack vector. Malware frequently modifies it to redirect users from legitimate sites to malicious ones, a technique you will replicate in a controlled, ethical environment in this workshop. Workshop brief. This workshop places you in a scenario that directly bridges your recent work on DNS resolution, packet sniffing, and NAT concepts. You have already observed how DNS queries travel across the network and how name resolution works in practice. Now you will manipulate the resolution process at its most fundamental layer, before any DNS query even leaves the machine, by editing the hosts file. This is both a foundational sysadmin skill and a critical offensive and defensive security technique. Understanding it deeply will prepare you for later work on phishing simulations, traffic interception, and local environment configuration in DevSecOps pipelines. Your working environment for this workshop is a Linux virtual machine, the same VM you have been using in previous activities. You will need terminal access with sudo privileges, a text editor of your choice, Nano, Vim, etc., a web browser or curl available on the VM, and optionally Wireshark or TP dump for packet-level observation. Step 1. Explore and document the current state. Before making any change, thoroughly document the current state of your system. Display and save the current content of your hosts file. Identify the priority order used by your system for name resolution by examining the relevant configuration file. Perform a DNS resolution for at least 2 different public domains, for example, github.com and a domain of your choice, using both nuslookup or dig and a simple ping, and note the IP addresses returned. This baseline documentation is essential. You will compare it to your results after modification. Capture screenshots or copy terminal output carefully. Step 2. Override a domain locally. Choose a public domain that you do not own and that will not cause any real-world harm to override locally. A good candidate is a domain you control, or use test.local, myapp.local, or similar non-production names. Add an entry to your host file that maps this hostname to 127.0.0.1, your loopback address. After saving the file, verify the override is working. Use ping, curl, dig, and/or your browser to confirm that the hostname now resolves to 127.0.0.1 instead of its real IP. If you have a simple HTTP server available, Python's http.server module works perfectly. Start it on port 8080 and confirm that your browser reaches it when navigating to your overridden hostname. At this stage, take note of whether a DNS query is even sent to the network. Use TP dump or Wireshark, filter on UDP port 53, to observe, or confirm the absence of, DNS traffic when resolving your overridden hostname. This observation is central to understanding the security implications of this mechanism. Step 3. Simulate a malicious redirect scenario, ethical, local only. Now simulate what malware or an attacker with local access would do. Add a host file entry that redirects a well-known hostname, such as updates.internal or a hostname of a fake internal application you define, to a different IP address. For instance, to the IP of another local interface or a second VM if you have one available, or simply to a different loopback port. Set up a minimal listener on that destination. Again, Python's HTTP server or netcat work well. Demonstrate, with evidence, screenshots, curl output, logs, that a client connecting to that hostname is transparently redirected without any DNS query, without any warning, and without any indication at the application layer that something is wrong. Reflect on this in your submission. What makes this attack vector particularly dangerous? What legitimate defenses exist at the OS, network, and application layers to detect or prevent hosts' file tampering? Step 4. Restore and harden. Remove all entries you added during the workshop and restore the host file to its original state. Verify restoration using the same commands you used in Step 1. Then, go further. Research and implement at least one concrete hardening measure that would help detect unauthorized modifications to the host file on a Linux system. This could involve file integrity monitoring concepts. You do not need to install a full SIEM. A simple approach using file hashing and a cron job is perfectly valid. File permission hardening, or immutable file attributes, chatter. Document your chosen approach, explain why it works, and demonstrate it. Step 5. Synthesis and reflection. Write a short synthesis, 300 to 500 words, included in your submission, addressing the following points. How does host file resolution interact with the DNS layer you studied previously? In a DevSecOps or penetration testing context, when and why would a professional legitimately use host file overrides? What are the indicators of compromise, IOCs, a blue team analyst could look for to detect host file tampering on a fleet of machines? Your synthesis should demonstrate both technical understanding and security thinking, not just a description of what you did, but an analysis of what it means. General advice. If your changes do not seem to take effect, always check. Did you save the file with root privileges? Did you flush the DNS cache? Is your browser using its own internal DNS cache? Try with curl instead to bypass it. If you are working on a VM with a snapshot feature, take a snapshot before starting so you can revert safely. Do not test host file overrides for real public domains on a machine you use for actual browsing during the workshop. Keep it contained to your lab VM. Read error messages carefully. They usually tell you exactly what went wrong.